Welcome back. The last session we had seen the first three AC parameters. Now we need to see the fourth one, the output impedance point. Okay. Now let's see. Let me erase. I've given sufficient time to write. Okay. Let's see the last one, fourth one, output impedance definition. Okay. Tell me what is the definition of output impedance? The definition of output impedance is the impedance seen from output port. Right? What is that? If you say with respect to input impedance, we know that this is nothing but your input impedance, right? This is nothing but the impedance seen from the input port. That is what is Ri, which I told V1 divided by small v1 divided by small I1. That is what we used and then we solved. Similarly, what is your R0? Right? The impedance seen from the output port. Right? Impedance seen from the input port, input impedance of your amplifier. Impedance seen from the output port, that is nothing but output impedance of your amplifier. Right? Remember, we should not include load because we are defining the output impedance of your amplifier, right? Then we should exclude the load. Then we should see from the output port. Let us say you are not excluding the load, and then if you say something like V1 divided by I1 as your input impedance, similarly if you say V2 divided by I2, let us say, right? Then what is V2 divided by I2? That I2 is nothing minus IL. That V2 divided by I2 is nothing minus RL, which is not correct, right? That's what mathematical analysis, sometimes it will misguide if you don't add the qualitative point, right? What is that qualitative point? The qualitative point is we should not include the load, we should exclude the load. Then I told one point before, all parameters whatever we were calculating like input impedance, output impedance and input impedance, voltage gain, current gain, right? Now always I told feed forward means Vs is giving V1, V1 is giving I1, I1 is giving I2, I2 is giving IL, IL is giving V2, right? But only for this parameter, only for the output parameter, you know, we are excluding the load, and we are going to apply externally V2. Remember, we are going to apply externally V2. Then we are trying to see what is that I2 because of V2. Then V2 by I2 is nothing but your output impedance, right? But one point is I think this is what we do. Okay, let me complete and then I'll explain that point. Again, you'll have one more doubt after defining the definition. Okay, then I'll ask you immediately one question. Therefore, now one thing is clear or not, we should exclude the load because I want to find the impedance seen into output port. Therefore, I want to define the impedance seen into output port. Therefore, R0, when I define R0, it is not V2 which we are getting from V1, which we need to apply. But mathematically, if you say something like this, when I say this is what your configuration, when I say R0 is V2 by I2, we will assume that RL is connected. No, RL is not connected. That is what is important. That anyway, I'll specify that point while defining that. Therefore, what is R0? R0 is nothing but V2, which we applied. Then what is I2? Because of V2 only. Therefore, what is R0? R0 is nothing but this is your R0. Therefore, what the definition? R0 definition is nothing but V2, right, divided by I2. Because when you apply the voltage, whatever current you get, voltage by current is nothing but your impedance. When the load is excluded, after excluding the load, when RL is infinity and there is something. If I say that something, you'll get a doubt. Then immediately I'll clarify with another example. Then RL should be excluded, then apply the voltage V2, then get the current I2 because of V2, right? To get it, I'm saying we have to make Vs 0. We have to make Vs 0. This is the definition. You may have, why to make Vs 0? To find your output impedance. If I say V2 divided by 2, okay, excluding the load, that is fine, right? Because we are applying the voltage, then we are getting the current V2 by I2, then that's it, right? Why are we making Vs 0? You may have that doubt, right? Definitely will have doubt. Then immediately let me ask you a question which you already know, but if you know that, immediately it is also known to you. But anyway, I'll explain qualitatively why you are making Vs 0. This is what is very, very important, which we are going to use this continuously throughout our amplifiers. The definition of this, the definitions, all AC parameter definitions, out of all, this output impedance is the one which is what is tricky, which is not straightforward. Okay. Therefore, now let's see. Let me ask you why I am making Vs 0. If you understand this, then done. It is straightforward. Now, let me ask you, therefore, let me take another example. Let us take an example, network example. Therefore, this is what is the circuit. Right? Now, let us say this is 10 volt battery. This is 1 ohm, 1 ohm, 1 ohm, and this is what is the load. Right? Where the load is variable here. When load is variable, I want to know every time for every different values of load, I want to know what is the voltage across the load and what is current through the load. Then every time applying nodal analysis is difficult, then we can use a theorem, Thevenin's theorem, that is easy. Once you can replace the complete box or the complete fixed circuit with some VThevenin and RThevenin, then VThevenin, RThevenin and the load, whatever may be the load value, it is easy to calculate the voltage using voltage divider network, and it is easy to calculate the current which is what is flowing through the load. Okay. Now tell me, what is VThevenin? What is VThevenin? How will you calculate VThevenin? The methodology is, we need to exclude the load to find VThevenin, right? Exclude the load, then whatever voltage you have from open terminal, that is VThevenin. Okay, that is true. Means it is like your diode status, finding the diode status. I told you, right, to find the diode status, right, we have to open the diode, find voltage across open terminals. If that is what is greater than V gamma, then diode will be forward bias. Less than V gamma, diode is reverse bias. I use the second approximation. Similarly, open it, get the voltage, right, then that much voltage it can see along with RThevenin, because it is not only VThevenin, because it has some other circuitry along with RThevenin, then RL will come into picture. That is what is the methodology which we are following, right? Therefore, what is VThevenin in this example? VThevenin in this example is nothing but, once you explode it, it is open, right? Therefore, let me say, to find VThevenin, right? Therefore, open the load. Therefore, if you open the load, you will get, this is 10 volt battery, this is 1 ohm, and resistor is there, but it is open. If it is open, there is no current which is what is flowing through it, and this is what is our VThevenin, right? Therefore, when you open, there is no current. If there is no current, whatever voltage you have across 1 ohm, that is our VThevenin, right? Out of 10, 5 here, 5 here. Therefore, what is VThevenin? VThevenin is nothing but 5 volt. Everybody understood? Fine. But my ultimate aim is not to find VThevenin. My ultimate aim is to find RThevenin. That is important. Therefore, to find RThevenin, tell me, how will you find RThevenin? What do you do? The effective impedance seen from the output port. We need to exclude the load. Exactly. This is also RThevenin. Simple. This is also RThevenin. Then let me come. We are excluding the load. Yes, we are excluding the load. Right? The impedance seen from output port. But tell me, unknowingly or knowingly, I don't know. We are calculating. How are you calculating RThevenin? Excluding the load. We are not applying the voltage and we are not getting the current. Remember, there is a methodology saying that if there is a voltage source, short it. Then 1 parallel, 1 and 1 parallel, 0.5 in series to 1, 1.5, that is RThevenin. My question is, from the methodology, short the voltage source. If there is a current source, open it, right? Then why are you shorting the voltage source while finding RThevenin? If you understand that part, this is also the same way. Okay? Therefore, to find RThevenin, we are shorting voltage source Then this is what is our network. Now this is what we need to find. Therefore, what is the resistance seen into? Therefore, this is what is our R Thevenin, right? This is 1 ohm, 1 ohm, 1 ohm. Therefore, what is R Thevenin? If you calculate, you will get R Thevenin is equal to 1.5 ohm. That is what is your R Thevenin. Because this one and this one, they are in parallel. That is what the combination is in parallel to 1. Therefore, overall that is 1.5 ohm. Then after finding V Thevenin, R Thevenin, what is your circuit? Your circuit can be replaced. This is replaced with V Thevenin and R Thevenin, right? This is R Thevenin, which is 1.5 ohm, and this is nothing but 10 volt battery. Now the actual load is connected. Let us say this is what is your RL, where it is variable. Now it is easy to calculate voltage across RL, current through RL for different values of RL, because we replaced effectively the complete circuit with V Thevenin and R Thevenin. Sorry, it is not 10 volts, it is V Thevenin, which is 5 volt, right? Done. I think there itself I created a doubt. What is that? Why are we replacing to short circuit? When if there is a battery, why are we shorting it to ground? If I don't explain, or if that is not clear to you, same thing. Exclude the load, right? The impedance seen from output port when Vs is 0. Therefore, what is your R0? R0 is nothing but R Thevenin, right? Therefore, indirectly we are calculating R Thevenin. That is nothing but your output impedance. Now the question, the common question between your output impedance as well as your Thevenin's theorem, why are we making the battery, the 10 volts battery to 0? That is what is the question. Okay. First of all, write it. I'll clarify that. Then I'll come back to this. Then we can derive. Then with that I can say the output impedance is also over. Write down. This is what is the parameter which is what is tricky, which is not straightforward. But if you understand it, that is straightforward. Okay. Take that example. Now I'll explain the reason why are we making the 10 volts to ground or 10 volts to short circuit. Let me get some water. I hope it is done. Okay. Let's see the reason why we are shorting it. Okay. Now, can I erase this? Okay. Using methodology, we found R Thevenin. Now, let me explain without any methodology how to find R Thevenin. Okay. Okay. Now, from the original circuit, what is R Thevenin? After excluding the load, the effective impedance seen from the output port. Right? Therefore, to find RThevenin without any methodology, to find RThevenin, right? Now, just listen. Now, this is what is the battery. I am not replacing the battery with 0, right? But effectively, if you replace the battery to 0, whatever you get, that is what you will get. That's why people define a methodology which is easier. But why it is shorter, I am explaining. Therefore, this is 10 volt battery. This is 1 ohm, 1 ohm, and now this is what is 1 ohm. Okay. For the time being, assume that this is black box for you. Black box means you don't know what is there inside. You don't know what is there inside. If you don't know what is there inside, right, there is a black box but defined with the 2 terminals, but I am asking you to find resistance. How will you calculate? Normally people say that take a voltage source, connect voltage source, and using ammeter get the current. Voltage by current is nothing but your resistance, right? But I told that is nothing but static resistance. V by I is nothing but static resistance. That is true for linear networks. Tell me, is it linear or non-linear? Now the question, what is linear, what is non-linear? If the element is non-linear, definitely the circuit is non-linear. Is voltage source linear or non-linear? Non-linear. Linear, linear, linear. Except voltage source, everything is linear. Therefore, except voltage source, everything is linear, but this is non-linear. Overall, it is non-linear only, right? Because this is non-linear, the network is non-linear, then we should not define static resistance. What is static resistance? Let us say I am applying the voltage, let us say I am applying V1 and I am getting some I1. I am applying the voltage V1, getting I1, right? Then V1 by I1 is not the resistance seen between these 2 terminals, because that is what your static resistance. Then static resistance is not true for non-linear networks. But you don't know, I told this is a black box, we don't know what is there inside, then it's better to go ahead with dynamic definition, because if it is linear, dynamic definition or dynamic resistance is also valid. If it is non-linear, we have to define with the dynamic resistance. Therefore, which is common for both linear and non-linear networks? Dynamic definition or dynamic resistance. But I can clarify in a different way also, okay? For example, if I say this is a black box for me, okay? I applied V1. Let us say I am applying, maybe for your understanding purpose, let me take V1. V1 is equal to some 20 volts, some voltage, okay? Then let's get I1. If you get I1, therefore V1 by I1, that is not RThevenin, right? Why? That is what. Let me explain. Using superposition, therefore instead of taking an example, even though you take example, you will not get it. When you say V1, right, then you are getting I1. I want to know I1 only because of V1. That is true only when your circuit is linear. Let us say battery is not there, short circuit, then it is completely linear. Then you can go ahead with static definition, which is simply V1 by I1, that will give you resistance. That is what is our RThevenin definition. Am I correct? But why are we going there? I am clarifying that, I am clearing that out. Therefore, now tell me, if 10 volt battery is there inside, right, when you say V1, then you are getting I1, your I1 is not only because of V1, your I1 is also because of 10 volt battery. Superposition, right? Therefore, this 10 volt is also giving some current, then V1 is also giving some current. Therefore, can I write it like this? Your I1, whatever I1 you have, I1 is equal to current due to the voltage what you applied external here, plus there is a current also due to 10 volt battery, because 10 volt battery is present inside, right? But what I want the current only because of V1. If you get current I1 only because of V1, over. But we are getting something, right? Now, let me apply another voltage V2. Then definitely I'll get another current I2. Therefore, what is that I2? I2 is equal to current due to V2, and you'll get definitely current due to 10 volts. The 10 volt battery is not changed. That is DC, right? Therefore, current due to 10 volts. Now tell me, what is RThevenin? Now I am defining RThevenin. You know what is RThevenin? Using, this is black box, but you know voltage source, regulator power supply, ammeter and all. We are trying to find RThevenin, okay? If you don't know the black box, then what is RThevenin? V2 minus V1 divided by I2 minus I1. This is nothing but your dynamic definition. This is what I told, right? Because this is nothing but delta V divided by delta I. That is nothing but your dynamic definition, which I already told. Because the network is non-linear, we have to go ahead with dynamic definition. If you go ahead with the dynamic definition, what will happen? Let me clarify. Therefore, tell me what is V2 minus V1? V2 minus V1. That is fine, as it is. Then what is I2 minus I1? Sorry. What is I2 minus I1? I2, IV2 plus I10 minus IV1 plus I10. Can I say I10, I10 will be cancelled? The common quantity, whatever you have in I1 and I2, that will be cancelled. Then whatever you get, which is nothing but IV2 minus IV1. What does it mean? Whatever change in the voltage you have at the output, now whatever change in the current you are getting, right? Therefore, the change in the current is only because of change in output voltage. Indirectly, we took the DC component or the common component from both I1 and I2 by subtracting. Therefore, the dynamic definition is giving the change in the output current because of the change in the input output voltage only. That is what is our Thevenin. You understand the point? Indirectly, we are taking the effect of the common quantity for I1, I2, which is nothing but due to 10 volts battery. Therefore, indirectly we are shorting it. Indirectly we are shorting it. That is what I told. During AC analysis, we don't need any common quantity that you can replace it. Therefore, straightforward we can do. Because ultimately I want AC resistance or Thevenin's resistance. Therefore, I want output current only because of output voltage. Then I don't want to see any internal voltages which will change my output current, not because of output voltage. That's why we are shorting it. To do not see any effect of this on output current, then we can directly go ahead with short it, apply simple voltage V1 by A1, that will give you the answer. That is what your Thevenin, which you are following the methodology, shorting it. Therefore, maybe generic way I can say, I want to know irrespective of anything. I want to know the change in output current only because of change in output voltage. If that is satisfied, problem is over. That is what is your resistance. Coming back to output impedance. What is output impedance? Exclude the load, okay. Apply the voltage, okay. Getting the output current, but I want to get the current because of only output voltage, right? Then, but this I2 is because of I1. I1 is because of V1. V1 is because of Vs. Means the input voltage indirectly affecting input voltage V1, and then input voltage is indirectly affecting I1. I1 is indirectly affecting I2. Even though you are applying V2, that current I2 is not only because of V2, that I2 is because of Vs also. Therefore, to do not see any output current due to any other reason, I want to see output current only because of output voltage. We need to inactivate the input source, then you get output current only because of output voltage only, right? Therefore, if I use, that is the condition, after excluding the load and making Vs 0, apply V2, get I2, V2 by I2 is output impedance. I hope it is clear with this example, right? Maybe if you want to understand still further, homework for you. What is it? Now, you apply some V1, get I1 using nodal analysis. Apply some V2, like V1 is equal to some 10 volts, V2 is equal to some 20 volts. Then when V1 is equal to 10 volts, get I1 using nodal analysis like a network problem. Then V2 is equal to 20 volts, calculate I2 using nodal analysis. Then V2 minus V1, which is 10 volts, 20 minus 10 is 10. Then calculate I2 minus I1, then the delta V2 minus V1, then the I2 by I2 minus I1, you will see 1.5 ohm. That is what is your Thevenin, which used the methodology like by shorting the 10 volts battery. Okay, but it will satisfy. Okay, okay, done. The example portion is done. You take that part. Okay, then I'll come back to the R0. Okay, this is what it took more time to explain. Okay, that's fine. Take it. I think so many definitions what I defined till now satisfied. For non-linear network, we have to take dynamic resistance. Yes. By shorting it, it is becoming linear. Then you can go ahead with static definition. That is what your Arthur methodology. And then why? To cancel out. Why are we going with the dynamic resistance? To cancel out the common quantity in the output currents. Then we are going with the dynamic definition like V1, V2, I1, I2. That is what. And I told if it is non-linear, BJT is non-linear, MOSFET is non-linear. That's why you see I already gave you the summary before starting our BJT small signal AC analysis. What is it? I told ID1 because of VGS1, ID2 because of VGS2, ID2 minus ID1 because of VGS2 minus VGS1. If there is any common quantity, that will be cancelled. Therefore, if there is any DC quantity, we don't bother. I told you that point, right? As we go on, we will understand. If there is any DC quantity, that will be cancelled. Then we don't need it. Unnecessarily, the complexity of calculations, to make the calculations very easy, people made separately AC analysis and then separately DC analysis. For AC analysis, we will look only with respect to the signals. If there is any DC quantity, that we will take it as 0. If it is voltage source, delta voltage 0. If there is a current source, delta change in current is 0, which is open circuit. When current is 0, then open circuit. Okay. Yeah, if that is over, maybe I can continue to this definition. Okay, we know we need to take RL infinity, means exclude this, and then we need to make Vs is equal to 0. Okay, now let's solve. What is V2 by I2? Do you know V2? We don't know, but we know I2, yes. Then instead of taking V2 by I2, let me take reciprocal of it. Therefore, let me take Y0 is equal to I2 divided by V2. Then once you find Y0, then simply 1 by Y0 is nothing but your R0. Okay, that is fine. When RL is infinity and Vs is equal to 0, therefore RL is infinity and Vs is equal to 0. Small Vs is equal to 0. Okay. Now, what is I2? What is I2? Your I2 is nothing but from star HF into I1 plus HO into V2 divided by V2. When no need to specify, okay, RL is infinity and Vs is 0. Okay. Now, I think V2 will be cancelled. Then you will get HO plus HF into I1 divided by V2. For this, you need to make RL infinity and Vs 0. Maybe if you use these conditions to get I1 by V2, I think problem is over. Let me erase this portion. I need the board part. Now, where is I1, V2? If you take input loop, I1 is here, V2 is here. Therefore, let us apply input KVL, then substitute Vs is equal to 0, then we can get the relation between I1 and then V2. Okay. Therefore, you can take this as equation 1. We will come back to this. Now, let us apply input KVL. Input KVL. What is input KVL? Vs is equal to drop across Rs plus drop across Hi plus drop across the voltage we have. Therefore, Vs is equal to, what is drop across Rs? I1 into Rs plus I1 into Hi plus Hr into V2. Right? Therefore, tell me, what is that? Vs is equal to drop across Rs, which is nothing but I1 into Rs plus drop across Hi, I1 into Hi plus Hr into V2. Right? Then if you take I1 common, you will get Rs plus Hi plus Hr into V2. Right? Therefore, this is what we got from input KVL. But we want I1 by V2 when Vs is 0. Here there is no RL term. Therefore, anyway, you can ignore that. Therefore, when Vs is 0. Now, when Vs is 0. When Vs is 0, 0 is equal to I1 into Rs plus Hi plus HR into V2. Therefore, tell me from this equation, okay, what is it? Maybe you can say directly, what is I1 by V2? I1 by V2 is equal to minus HR divided by Rs plus Hi. This is what you get. Right? Now we got I1 by V2 when Vs is 0, right? Then substitute that in equation 1. 1 implies what is Y0? Y0 is equal to HO, right? HF, but it is minus, therefore minus HF into HR divided by Rs plus Hi. This is your Y0, where R0 is nothing but 1 by Y0, reciprocal to your admittance, is nothing but your output impedance. Therefore, we got all 4 formulae related to your BJT core amplifier: input impedance, output impedance, voltage gain, current gain. Okay, take it. Therefore, I kept in 4 boxes. All boxes are formulae which we need to remember. Different people will have their own way of remembering the formulae. You can remember. But if you ask me what is the best way to remember, the best way to remember is solving, I can say, derivation and solving the problems. When you derive, you will understand the limitation of the formula. When you solve multiple problems related to the formulae, automatically you will remember the formulae. Okay. Therefore, problem solving is very important. Okay. Maybe after this theory part, the problems will start. Okay. They are interesting. Just not to get the answers, just to understand the theory. Okay. Let's see that part. Over. Okay. Now, after this, write down as I told you, right? Because in this case, the load is connected, then the current which is what is entering into your load is IL, and then voltage what you are applying to your load is V2. With respect to load, V2 IL, fine, provided by your amplifier. Similarly, if you excite with practical voltage source, then part of Vs Rs or part of Vs we are applying to your amplifier, which is nothing but your V1. When you excite with current source, part of Is you are going to pump into your amplifier, right? Let us calculate, not with respect, because we already calculated your BJT amplifier core parameters like current entering into amplifier, current leaving from your amplifier, and voltage applied to your amplifier, voltage coming from your amplifier. But now let's speak with respect to the source, actual source, and actual load. I think actual load current, actual output voltage is matching to BJT output voltage and then BJT output current, except the direction, right? That is fine. But coming back to this, actual input voltage or BJT amplifier is not your real voltage source, right? Because we are exciting with practical voltage source, therefore V1 has come into picture. But don't say, when I say Vs is replaced with practical current source, Is and then Rs. No, for practical current source, it should be Is and in parallel to Is, which is nothing but Rs. Further, we should take practical current source, right? Let's see that, then we will see that part also. But they are not very much important. These are all very important. If you say something, further we need to go on with the different configurations. Then we'll come back. Ultimately, the amplifier, the BJT amplifier, core parameters are very important, whatever we had solved till now. Okay, done. Now, let me erase. This is not required now. Right, now let me define. First of all, if this is what is practical voltage source, right, then fifth one, just to continue, let me speak AVS, right, maybe, okay, therefore what is AVS? The voltage source, voltage gain with source resistance, real source, therefore voltage gain with respect to real voltage source. Okay, what is that? The voltage what you are applying to your load is nothing but V2, that is nothing but your amplifier output, that is fine, divided by what your voltage, input voltage which you are applying from your voltage source, that is Vs, that is what your Vs, this is what your real voltage gain. Okay, now to calculate this, can I write it like this? Can I write it as, what is V2? You are getting V2 because of what? Because of V1, therefore V2 because of V1 and V1 because of Vs. V1 because of Vs. Can I write it like this? V1 will be cancelled mathematically, then it is V2 by Vs. Therefore, already we know what is V2 by V1, right? That is nothing but your voltage gain, and which you already calculated, the BJT amplifier core gain, V2 by V1. Now we need to know what is V1 by Vs. If you know V1 by Vs, problem is over, right? Therefore, what is V1 because of Vs, right? Now, let me model only input part. Can I model your input part like this, where the practical voltage source, this is your Vs and Rs, this is what your practical voltage source. Now your amplifier is having input impedance, that is what your Ri. Let me replace input part, and we know that this is nothing but your V1, right? Can't you get V1 to Vs relationship? It is nothing but voltage divider network, right? Then what is this? Therefore, what is V1 by Vs? V1 by Vs is nothing but Ri divided by Ri plus Rs, right? Then what is your AVS? Therefore, AVS is equal to AV, the voltage gain, into what is that? Ri divided by Ri plus Rs. This is what is your voltage gain, including source resistance. But what is the observation? Definitely I know that your AVS is less than AV. Therefore, AVS is less than, this is your observation. AVS is less than AV. Therefore, to improve AVS to AV, what to do? Those things I'll explain. Mathematically I can explain. To get AVS is equal to AV, right? What to do? Rs should be 0, right? What is that? When Rs is 0, then what is your V1? V1 is nothing but your Vs. Done. Your core gain is nothing but your real voltage gain. But what do you mean by Rs is 0? Rs is 0 means ideal voltage source. We need to excite with ideal voltage source. Practically we don't have ideal voltage source, right? If you excite with practical voltage source, then we cannot. Therefore, those things we see later on when we solve the problems. Therefore, the theoretical part also I'll explain. Okay. Now let's calculate the formula, then we'll get it. Therefore, fifth one is over. Now, let us say the sixth one. Means sixth one is related to what? Sixth one is related to, let us say, this portion is common, your amplifier is common, load is common, everything is common. But now we are not exciting with ideal voltage or practical voltage source. Let us say we are exciting with practical current source. Now this is a current source. If that is a current source, what does it mean? Therefore, now this is what is the current source, which is IS and practical current source. Therefore, because we can pump current from your current input, then this is what your amplifier that is already modeled, which is what is having input impedance Ri. This is what is your Ri, and the current which is what is entering into the current which is entering into this, the current which is entering into the amplifier is nothing but your I1. Actually, this is what is your, sorry. Therefore, this is what is your amplifier. Your amplifier is replaced with Ri, effectively represented with Ri. Similarly, this is what your amplifier. Your amplifier is effectively represented with Ri, which is modeling, because we effectively represented the input impedance, we calculated also. That is what your Ri. Now, if you ask me the definition of current gain, including source resistance, that is nothing but AIS is equal to the current which is what is entering into the load, right? With respect to load I am speaking, that is nothing but IL divided by, and the current which is what you are getting from the source, practical voltage source, sorry, practical current source, not I1. That I1 is nothing but current which is entering into your amplifier, that is core amplifier current gain, which we already calculated. Now we want to calculate the source current, therefore IL divided by IS, right? Therefore, this is with respect to load and then source. The current which is what is entering into the load is IL, the current what it is pumping from your practical current source is IS, then IL divided by IS is nothing but your current gain, right? Then can I write like this again? IL, we are getting load current because of what? Because of I1, right? Then I1 is because of what? I1 is because of IS. Therefore, I1 divided by IS. We already calculated the load current because of input current, the load current because of input current which is entering into your amplifier, right? That is nothing but your core amplifier gain, which is AI into then I1 divided by IS. It is nothing but current division network, right? These two are in parallel and then excited with a current source, then we can get current which is what is flowing through Ri using network analysis. Therefore, if you solve that, you will get AI into what is I1 by S, which is nothing but opposite resistor RS divided by RS plus Ri. This is what is your AIS. Therefore, here what is your observation? Here also your current gain AIS is less than AI. Obviously, because whatever current you are getting from your practical current source IS, part of the current is going through RS. Only part of the IS is entering into your amplifier is amplifying the current which is what is entering into your amplifier and then providing it to load. Therefore, because of this RS-RI combination, part of the current is flowing through RS and then only part of the current is entering into your amplifier. Tell me, just generic or from network analysis, if you want to get I1 is equal to IS, can I say RS is infinity? If RS is infinity, then I1 is equal to IS. What do you mean by RS is infinity? Ideal current source. But I told, what is the guarantee that you will excite, right, your amplifier with ideal current source? We don't have ideal current sources, right? Definitely we have some source resistance. Then we have to excite with practical current sources, then only it matches to practical analysis, right? Theoretically we can speak, if RS is infinity from your current source, right, then you'll get only IS, then the IS will enter into your amplifier, then we can get maximum current gain, what you can get from your amplifier. But that is not practical, okay? Therefore, you will understand, but what it may be, the real current gain including source resistance is less than the available gain what you can get from your amplifier, less than the maximum core gain, okay? Take this. These are important, but with respect to problem solving, nobody is asking what is AVS and then what is AIS. You will understand why people are not asking AVS and AIS. and how it is improved practically without changing the practical current source, without changing practical voltage source. Okay, those things we will see as we continue. And one more important point, because I told a sentence, what is that? Mathematical analysis will misguide. Yes, in this equation we have RS. In this equation we have RS, but both are different. Even though we are defining RS a mathematical term, but both are different. Why? This RS is with respect to practical voltage source. That RS will be close to 0, but not 0, close to 0. If it is 0, ideal voltage source, but it is close to 0, right? Now, coming back to this, here the RS is close to infinity or close to very high value, because it is internal resistance of your current source. Even though you are representing the same name RS, but here it is practical voltage source, resistance, internal resistance or source resistance, and this is practical current source, internal resistance or source resistance. Okay. Strictly speaking, we should define with a small RS, because according to the analysis what we did before, this is voltage source resistance, we should define internal resistance, equivalent resistance, dynamic resistance, right? That is nothing but this only. We are representing equivalent in series to voltage source. Okay, with ideal voltage, and then in series to the actual resistance is represented like this. Strictly speaking, that is nothing but your dynamic resistance, but people followed, but remember that is nothing but dynamic resistance in the case of current source also. Okay. Let me stop now. Okay, now in the next session what we see, I'll give you generic H parameter values. Actually those H parameters values practically will be given from the data sheet. When you purchase any BJT from the market, it will have some data sheet. Then the data sheet will contain the H parameter values, right? Then we need not calculate, but there is a methodology to calculate H parameters also, which is not there in our syllabus. For the timing, I am not explaining how to calculate H parameters practically. Assuming that H parameter values are given in the examination, yes, they will be given. We need not remember anything. And remember, those H parameter values are not constant. They are different for different transistors. H parameters values change with respect to different transistor configurations. At the same time, with respect to temperature, with respect to doping, with respect to size, there are so many parameters. Therefore, we don't need to remember all those things. Whatever which is what is given in the examination, use and then solve the problems. But let me give you a typical values for BC107 transistor. Then let's continue for solving our workbook problems. Then we can solve the problems. See, the problems what we solve from now onwards after defining H parameters, not to like get the answer, it is like solve the problem, get the answer, analyze the answer, understand the limitation, then continue next. Therefore, after solving the problem, having observations, having conclusion, that will guide you to go to next configuration. That is the way we need to analyze, or that is the way we need to solve the problems. Therefore, let us solve in that way majority of the problems, but the problem should be practical. Only if the problem is practical, then only whatever we solve or whatever answer we get, that is what is we can analyze, then we can go ahead, we can take the result as granted, and then we can continue further. Okay, am I clear? Okay, the video will be resuming for 5 more minutes. Maybe you can focus on, like, if you don't write, you can take it, then we will continue in the next session. Okay.